In this video, we're going to talk about 3.1, which is quadratic functions, but the end goal is to talk about applications of quadratic functions. Once again, here we have the characteristic graphs of a quadratic equation. On the left side, we have one graph where the parabola is said to be opening upwards. So both endpoints of the graph are going in the upwards direction, and as it comes from the left, it goes all the way down to a certain point, it stops, then it turns around and then goes back up. This point down here is called the vertex, or in this case it's the minimum point. This would be the equation that graphs that type of function, a quadratic equation, in either form, either general or standard. There is a line down the middle, which we call the axis of symmetry, which breaks the parabola in half. There's like a mirror down this line, or this line is like a mirror, where this leg is identical to this leg right here. The difference between this graph and this graph is the direction in which it opens, right? On the right side, it is said that the parabola opens downwards. It comes from the bottom, and as you go to the right on the x-axis, the values go all the way up to a point. They stop going upwards, and then it starts falling. They start going down. And so this parabola is known to have a maximum point. That vertex right there is still a vertex, it's the turnaround point, but it has a maximum point. And this would be the equation that graphs that particular graph. The only difference is that it has a negative a value, or the negative number in front of the x squared, compared to this form right here on the left. So that is the big distinction between the two. When we talk about the standard form of a quadratic function, we mean it's a quadratic function in a special form. And that special form is this one right here, where there's a number times something in parentheses, and it's going to be x minus h, and all of that is going to be squared plus a number k, where the coefficient a cannot be 0, otherwise this would not be a quadratic function. So this is said to be in standard form. The graph of this is going to be a parabola, and it has the vertex at the point h, k. So this standard form is also known as vertex form, because you can easily just look at it and pull out the number from there and make it a point, and that will be the vertex. You can tell whether it opens upwards or downwards by the sign of a. If a is greater than 0, then the parabola opens upwards, and if a is less than 0, then the parabola opens downwards. So this would be the case. If a is positive, this would be the case if a is negative. Okay? And again, the line would be symmetric, meaning the left is going to be equal to the right leg, and it goes through that point that we call h. Let's do an example. We want to graph the following quadratic function. F of x is equals to negative 2 times x minus 3 squared, or everything inside of the parentheses squared, plus 8. So let's figure out a couple important things about it, and then we'll graph it. Okay, so the solution to this, first we want to compare it to the standard form. So I have a number, a times x minus h, all of that squared, plus k. And from this general equation, we know that the vertex is the point h comma k, and then the axis of symmetry is x equals h. So at least those are two things that we can easily figure out, right? So in this problem, we see that h is going to be the number 3, or that's what it corresponds with. So the vertex of the problem we're doing is 3, 8. So the parabola gets to the point and it turns around. Is it going to be like this, or is it going to be like this? Opening upwards or opening downwards, right? I'm sure you can already tell what the answer is, but at least let's play this idea and try to figure out what it is. Okay, this is the point at which it turns around. Either it turns around at that point like this, or it turns around at that point like this. Then let's figure out the axis of symmetry. X equals whatever the h value is, in this case, or the x component of the vertex, which is this value here. So it's going to be x equals 3. So there's a vertical line that goes through the value x equals 3. Okay, so we have a couple of components of this graph. Now we can be more assertive as it opens upwards or downwards. And so the a value in this case happens to be -2. There's a negative number out in the front. So the overall graph is going to be downwards, right? And that point, that vertex, is what we consider a maximum, right? So this would be the answer. Now, do we have enough information to make a good graph? Well, kinda. We could use a couple other pieces of information. We can figure out the y-intercept. And we figure out the y-intercept by letting x equal to 0. So we plug in x equals to 0 into the original equation, and we're going to have the following. So f of x, or y, is going to be equal to -2 times 0 minus 3 squared plus 8. -2 times -3 squared plus 8. Then it's going to be -2 times +9, because -3 times -3 is 9, +9. This becomes -2 times 9, which is -18, plus 8. This is going to give us -10. So here's another important part for our graph. We're going to have the y-intercept go through the point 0, -10. So let's try to make a graph here. So 0, -10. We'll make -10 right here. and we'll have the point 3, positive 8. So we'll say maybe here's 5, 6, 7, 8. It's going to be right here. So we know that our graph is going to go through those 2 points. And we could get even more accurate, but for now I'll just leave it like that. And so we'll get something like this, and then this should be, we'll try again, try to go through that point, make it look pretty, I guess, something like that. And if we have to draw the axis of symmetry, or just to include it in there, we'll have a line that goes through everything like that with equation x equals 3. So kind of accurate. One more thing that we could try to work on will be to find the places where it equals 0, where the whole output equals 0. And so we do that by setting this equal to 0 and then solving for x. And it would be just making use of the tools that we learned earlier, which would be to apply the square root function, or the square root property, to both sides to try to get the x out from under that power 2. And that would give us a little bit more accuracy on the graph that we're trying to do. The next thing that we want to talk about is finding the vertex of a parabola. Okay, once we reach this point, like I said, we're almost done. We're making it as accurate as we kind of possibly can. Of course, it can be very accurate, but doing it by hand, it's as accurate as we could. Now let's solve for x. Let's do it. So we're solving that equation, and we want to get the x-intercepts. We're going to set it equal to 0. We'll have 0 equals negative 2 times x minus 3 squared plus 8. So now we're just going to do the opposite of order of operations, right? So we're going to move this 8 to the other side because I want x by itself. So I'm going to be left with negative 8 equals negative 2 times x minus 3 squared, divided by the number that's in front, negative 2. We're going to have 4 equals x minus 3 squared. Here's where we apply the square root property, so plus or minus of that square root. Here on the right side, those cancel out, and we're going to be left with plus or minus 2 is equals to x minus 3. So we're going to move the 3 to the other side, and we're going to have 3 plus or minus 2 is equals to x. So here's where we kind of split that equation and say 3 plus 2 equals x, and 3 minus 2 equals x. So 5 equals x, and 1 equals x. So these are the two places where it crosses the x-axis. So if we go back to the graph here, this should be the value of 1, like that, 3, 4, and then this should be 5. So if you want to add a little bit more accuracy to the graph, this is how we would do it, right? We would have 1, 2, 3, 4 points of accuracy. So our graph is that much more accurate than just saying it opens like this and that's all I know, right? So this graph is a little bit more accurate. Now what happens if you're given an equation that is not in this form, okay? Like the general form. What if you're given an equation in general form? And what is general form? General form is a number times x squared plus a number times x plus a number. So this one, you cannot easily pull the vertex out of it, right? You have to do a little work. But with this formula or method, it's going to be really easy. So this is the vertex, this coordinate pair. And so you find it by doing negative of the b value divided by 2a. So this number is coming from here, a and b. So negative of this number divided by 2 times a. And that would be your x value. Then, once you find that, you plug it into the equation that you're working with. You replace every x with that number, and you simplify, and whatever you get is going to be the corresponding y value for that, and you find the vertex. That's how you do it. So here, let's give it a try. We want to find the following, we want to graph the following quadratic equation and finding all of the different pieces of information, right? We want to find the vertex, the y-intercept, the x-intercept. So we'll make a list. Vertex, y-intercept, x-intercepts, and the axes of symmetry. Why not? So how do we find the vertex? We do this by first figuring out the x value to be negative b over 2a. And so that is negative of negative 2 divided by 2 times negative 1, right? So negative of the b is negative 2, divided by 2 times a, so 2 times that negative 1. So we have the following: 2 over negative 2, which comes out to be negative 1. So that's the that's the x value of the vertex. Now we plug it in and we figure out what is the y value that goes with it. So negative of negative 1 squared minus 2 times negative 1 plus 1. We get negative 1, because negative 1 squared is positive 1, times that negative 1. Negative 2 times negative 1 is plus 2 plus 1. You could go and say negative 1 plus 2 is 1, plus 1 is 2, or that negative 1 cancels with that positive 1, and you're left with 2. So we found the vertex to be negative 1, comma 2. Next, let's find the y-intercept. We find that by letting x be equals to 0. If we do that, y is going to be the following after we plug in 0. So 0 squared is 0, 0 minus 2 times 0, so it's 0 minus 0, that goes away, and we're pretty much left with y equals 1. So the y-intercept is the point 0, 1. The following is going to be a little bit more tricky. So let's see, this is the equation. And we want to figure out the x-intercepts. One thing that I want to do, well, first we're going to set it equal to 0. So 0 equals negative x squared minus 2x plus 1. And I'm going to multiply both sides by negative 1 because I don't want that negative in the front. It's going to be harder for me to do factoring, if you will. So this is the same thing as 0 equals x squared plus 2x minus 1. Multiply both sides by negative 1, and that's how we did it. Then, because I'm running out of room here, I'm going to factor, and we'll have two things that multiply up to x squared, sorry, so x and x. And then two things that multiply up to negative 1, it's going to be positive 1 and negative 1. But as you see, negative 1 plus positive 1 doesn't add up to 2. So it's going to be some tricky numbers. Let's see, did we do something wrong? So I'm not going to be able to do the factoring because it's not going to be easy to do. So we're going to do quadratic formula, either of the top or the bottom. It'll be the same. I'm going to forget that we even mentioned this one then and go for the quadratic formula. So we'll have x is equals to negative b, which will be 2, plus or minus square root of b squared, so negative 2 squared minus 4 times a times c, and all of that is divided by 2 times a. Let's simplify this, and we'll have 2 plus or minus square root of 4 plus 4 over negative 2. So negative 2 squared is positive 4. Negative 4 times negative 1, positive 1 times 1, 4. So we have the following: 2 plus square root of 8 over negative 2. We need to figure out the square root of 8. And I think we've covered this in some of the square root problems where you kind of break it up into its factors and you look for a good one that has a square root so that you can simplify it farther. So we're going to have 2 square root of 2 be the answer to square root of 8. And this is all over negative 2. So we could simplify things a little, and this is going to be 1 plus, alright, let's simplify things a little bit. Negative 1 minus square root of 2, or the other answer is going to be negative 1 plus square root of 2. And those are the two x-intercepts. Okay, a little tough, but they were decimals, so that's why it's going to be more difficult to do it as a factoring problem, and it was easier to do it, or more possible to do it, using the quadratic formula. So here we have all the components to graph this. The next thing that we want to talk about is the applications of quadratic functions. We want to look at a problem that involves quadratic equations and be able to apply whatever we know to a real-world problem like this one. So it says an archer's arrow follows a parabolic path. The height of the arrow, f of x, in feet, can be modeled by the following function. So f of x is equals to negative 0.005 x squared plus 2x plus 5, where x is going to be the arrow's horizontal distance measured in feet. And here are the questions that were being asked. A, what is the maximum height of the arrow, and how far from its release does this occur? So they're asking how high does the arrow get, and how far away is it from the point of its release. B, find the horizontal distance the arrow travels before it hits the ground, and then round that to the nearest foot. So you're trying to figure out how far away from the beginning part does the arrow land, and then the last part will be to graph this. So I like to start with a rough sketch. So a rough idea of what I'm looking at. So it doesn't have to be a perfect graph, and I think that's the beauty of this, that at least for now this is going to be perfect for us. So here's a person, and it's going to shoot an arrow, and the arrow, think about what it does. I've never shot an arrow, but I can definitely visualize what happens with this arrow, that it goes up and then it comes back down, like that, right? And so its path makes a parabola. At some point here, that's going to be the vertex. Okay, so there are many different things we're looking at here. From here to here, and I believe we said that the x is the distance, so x is the distance, and this right here, the f of x, is the height. Labeling the axes is super important because it gives you an idea. You know, it says, it doesn't say anything here, but this is what we should be thinking, is that this vertex point, the x component of it, is how far away from the initial point does the vertex occur. If you look at it in the vertical axis, this is the height of the arrow at its highest point. This is the overall distance that the arrow traveled. So we can figure out those things fairly easily, but it means a lot of different things. It means a lot of information once you understand how to get it out of the problem. So we figure out perhaps by finding the vertex, because we're looking for what is the maximum height. So the maximum height is the y value of the vertex, but we got to figure out the vertex first, the x value. So x is equals to negative b over 2a, which is negative 2 over 2 times negative 0, 0, 5. Once we put this in the calculator, we get something like 200. So at 200 feet away from the point of release, that's when the arrow is at its highest. This is not how high off the ground it is. This is how far away horizontally it happened from when it was released. So now we got to plug that back into the equation. So we'll have negative 0.005 times 200 squared plus 2 times 200 plus 5. So let's put that in the calculator. And after some simplifying, I hope that you get 205. So after 200 feet horizontally, the height vertically is going to be 205. So at the point 200, 205, we see the vertex. But in order to answer the real question is, what is the maximum height of the arrow? The maximum height is 205. How far from the release does it occur? 200 feet away. Okay, so that was part A. Perfect. Now part B is asking how far away from, well, it says find the horizontal distance the arrow travels before it hits the ground. So this right here is the horizontal distance until it hits the ground. So that means find the x-intercepts. So part B just says find the x-intercepts. Okay, let's write the problem again. It would be f of x equals negative 0.05 x squared plus 2x plus 5. And I don't think I want to factor this thing. I don't know that I could easily do it. So we're going to go with the quadratic formula, right? First thing is to set it equal to 0. And make sure this doesn't get confused with a 6. It's a 0. So let's go. Quadratic formula. Negative b, so negative 2 plus or minus square root of b squared, so 2 squared, minus 4 times a times c, all divided by 2 times a. So once you plug in the numbers and you can clearly see this, which I recommend you writing this on whatever it is you're working on a piece of paper or whatever, and not straight plug numbers in here from here to the calculator, just because you could make mistakes. You know, you want to at least have an idea of what you're plugging in, where the numbers go. So I'm going to simplify little by little. 4 minus, what is 4 times all of that? 4 times negative 0.05 times 5, and that comes out to be negative 0.01, so 0.1. And negative times a negative should be positive. So keep in mind the signs and things like that if you're trying to troubleshoot why you got the wrong answer, which can often be the case. It comes from looking at it here and plugging it in the calculator that you start making mistakes. Okay, next let's simplify even more. So we'll have 4.01 divided by negative 0.01, and at this point we're going to split it into two problems. We'll have negative 2 plus or minus, not plus or minus, plus 4.01 over 0.01, and we'll have negative 2 minus 4.01 over negative 0.01. So those are my two values of x at which it touches the ground, theoretically. So let's go ahead and do this. Put it in the calculator as best you can and compare your answer to mine and see if you did it correct. So on the first answer we get this, negative 0. What does it say? Graph to the nearest foot. So find the horizontal distance to the nearest foot. So this is negative 0.2. So I'm going to say 0. We'll just leave it at that for now. That's one of the answers. And this is going to be the next answer. Same answer as this one, except, well, same values, except that's a minus or a negative. And I'm going to get 400.2, which is roughly 400. And only one answer makes sense, right? Because the arrow cannot be at a negative distance, right? The arrow is not falling behind you, it's falling in front of you, right? The arrow is not falling here, it is falling right over here. So that's why I wanted to keep the answer or that number there so that you can see, but this is the right answer. So the arrow falls 400 feet away from the original point, right? The moment of release. So it landed 400 feet away. Okay, so in order to graph a more accurate picture, we can just kind of use what we know and kind of go like this. We know that at 400 we have a point. We know that really close to 0 we have another point. And then somewhere here at 200, 205, we have a nice vertex, and so I know that our graph could look something like this. But in general, that would be one of the ideas, right? The graph looks like this, but I think the more accurate graph would be this one, because it shows the ground, the arrow doesn't go below the ground or anything like that, so it's more realistic than the other graph, but theoretically they're both okay. I think that's everything for this video. Thank you for watching.